Hello, dear professor. My name is Han Tong. Today I have the honor to present my master thesis. My project is predicting bank inactive customer churn using machine learning. In this presentation, I will explain the background of the study, the goals, the data, the models I used, my experiments and results. Finally, the conclusion and ideas for future work. Introduction. Let me begin with some background. In the banking sector, churn is a serious problem because it can lead to large financial losses. It's also much more expensive for a bank to attract a new customer than to keep an existing one. If we can predict churn in advance, banks can take action to reduce it, for example, by offering better service or promotions to customers who are at risk of leaving. Machine learning offers tools that can help with these tasks by finding patterns in data that may not be obvious. In this project, I focused on using machine learning models to predict churn for bank customers. Research objectives. Here are the main goals of my study. First, I wanted to build models that can predict whether a customer will churn or not. Second, I compared different machine learning models to see which one works best. The 6 models tested are logistic regions, decision trees, naive KAN, rhythm focus, and XGBoost. Finally, I adjusted the model setting. Now let's look at the data I used. I worked with a dataset from a bank that included about 10,000 customers. The data included features like age, gender, credit score, balance, tenure at the bank, number of products the customers use, whether the customer has an active account, and so on. The target label was true. A value of 1 means the customer left a bank. A value of 0 means the customer stayed. Before training the models, I cleaned the data by removing and checking for missing value. I also normalized some features to help the models learn better. Methodology. In this project, I used 6 different machine learning models to predict customer churn. Each model has its own way of learning patterns from the data. I started with logistic regions, which is basically a linear model. It is simple, fast, and easy to interpret. Then I used a decision tree. This model works by splitting the data into branches based on different conditions. It is easy to understand, but can sometimes overfit if not controlled properly. Next, I applied naive, a model that is based on probability. It assumes the features are independent, which makes it simple but sometimes not suitable when features are related. I also tested KNN. This model looks at the closest data point to make a prediction. It is easy to understand but can be slow when we have a lot of data. To improve performance, I tried the random forest. This model builds many decision trees and combine their results by taking a majority vote. It is good at handling more complicated patterns and reduce the risk of overfitting compared to a single decision tree. Finally, I use XGBoost, which stands for Extremely Gradient Boosting. This model building tree one by one, where each tree tries to fix the mistakes made by the previous ones. It is more advanced and usually gives strong results. I select these models to compare both simple and more complex methods and to see which type of model works better for this task. Next one is evolution metrics to evaluate the models. Evaluation metrics. To evaluate the models, I use the 4 metrics. First, accuracy. which tells us the percentage of current predictions out of all predictions. It gives a general idea of how well the model works. Second, precision, which shows how many of the cases that the model predicted as true were actually true. A high precision means that the model makes fewer false alarms. Third, recall, which shows how many of the real true costs the model was able to find. A high recall means the model is good at catching most of the true cases, even if it sometimes gives false alarms. Finally, I look at the F1 score. This score gives a balance between precision and recall. It is useful when you want to consider both false alarm and missed true costs at the same time. I also use cross-validation to test the models. This means I trained and tested the models on different parts of the data many times. This helps make sure the results are reliable and not just due to chance to luck with a single data split. This step helps us choose a model that will work well not just on this data, but also on new data in the future. Results. Now let's look at the results. Among all the models, XGBoost gave the best results. It had the highest accuracy and F1 score. Random forest also performed well, especially in recall, which means it was good at identifying customers who actually tuned. Logistic religions was the fastest model but had lower accuracy than the ensemble models. The other models like Decision Tree, Never Ibis, and KNN had moderate performance in this task. I also look at feature importance. In Random Forest and XGBoost, the most important for future was predicted score balance and tenure. Conclusion. In concluded, machine learning can predict customer churn with good accuracy. In this study, XGBoost was the best model. It gave the highest accuracy and worked well with different types of data. Random Forest also gave good results, though not as strong as XGBoost. Simple models like logistic regions were faster to train and easier to understand. However, they did not perform as well in terms of accuracy for this problem. These results shows that choosing the right model is important when trying to predict customer trends. They can help get future work in this area. For example, banks and other companies can use this model to better understand which customers might leave and take action to keep them. It can improve customer satisfaction and reduce loss. Future studies could test more models or use more data to improve the predictions even further. About future work, I see three directions. First, it would be useful to test the models on larger and more complicated data sets. This can help check if the models still work well when the data is bigger or more detailed. It can also show how the models handle different kinds of customers. Second, we can add more features to the data. For example, we could include customer behavior data like how often they contact customer service or their transaction history, such as how often they use the account. This extra detail may help the models make better predictions and spot customers who may leave more easily. Third, it would be interesting to try deep learning models use a more advanced model. These models can find patterns in data. This is the end of my presentation. Thank you very much.